If I asked you to find the area of this triangle without using a calculator, and I only gave you this one hint, do you think you could do so? Well, you might immediately see some challenges to this. We all know that the simplest way to find the area of a triangle is by using the formula half base times height, but at the moment the formula is of no use to us because we have neither the base nor the height values. Another difficulty is that since I'm asking you to not use a calculator, you're going to find it difficult finding the angle x because you can't use the inverse sine function. Despite all of these obstacles to finding the area, it's not as difficult as it appears. If you think you can do it without my help, pause the video and have a go. You can still watch the solution, and if you came up with a different way of finding the area than I did, please put it in the comments. It'd be interesting to know how you did it. So the first thing I'm going to do is hide half base times height because we can't use it at the moment. We have the angle x, and the only clue we have is that sine of x equals 0.6. We also have the hypotenuse, which is of length 5. We can use these two pieces of information to our advantage, which will help us find the length of another one of the edges. The first step I'm going to take is to write sine of x in a way that should be very familiar to you, and that is sine of x is equal to opposite over hypotenuse. Why have I done that? Well, if we look at both of these equations, we have the sine of x equals opposite over hypotenuse, but we have sine of x equals 0.6. So 0.6 and opposite over hypotenuse is the same value. So we can write an equation for that. 0.6 equals opposite over hypotenuse. But we can take this a step further because we know what the hypotenuse is. The hypotenuse is 5. So opposite over hypotenuse equals opposite over 5, which is the length of the hypotenuse. Now this means that 0.6 equals opposite over 5. By the way, since the angle's x, then the opposite must be the base of the triangle. Now looking at the equation that we've come up with, if we want to know the value of opposite, we need to multiply both sides of the equation by 5. So we would get 5 times 0.6 equals opposite times 5 divided by 5. The 5's on the right hand side cancel, and so we get that 5 times 0.6 equals the opposite. Well, 10 times 0.6 is 6, so 5 times 0.6 is half that, which equals 3, which means that the length of the opposite side equals 3. So now we have one useful value, the base, but we still don't have the height. Let's clean up the calculations a bit so we have room to figure out the height. Now how are we going to get the height? You might think that we somehow may be able to use cosine of x. Cosine of x is the adjacent, which is the height, over hypotenuse, but we don't have a value for cosine of x, so we can't use the same method. I'm going to remove the hint because it served its purpose. Now what can we do to find the height of the triangle? We can use Pythagoras' theorem. If you know Pythagoras' theorem, you should know that if you have a right-angled triangle and you have the lengths of two of the edges, you can find the length of the third edge of the triangle using the formula a squared plus b squared equals c squared, where c is the length of the longest edge of the triangle we normally call the hypotenuse. Each of the remaining edges gets one of the other labels a or b. So let's label the base of the triangle with a and the height of the triangle with b. We already have the value of the hypotenuse c and we have the value of the base a, so we need to rearrange the equation for the value of b. So looking at the formula, if we subtract a squared from both sides, we're left with b squared on its own, and that rearranges the equation to b squared equals c squared minus a squared. And now if we plug the values we already have into the equation, we should be able to get the value of b. And then we'll have the height of the triangle. So we have b squared equals c squared. Well, c is 5, so that's 5 squared, minus a squared, and a is 3. 5 squared is 25, and 3 squared is 9, and 25 minus 9 is 16. So b squared equals 16, and if you take the square root of that, that means that b equals 4. And that means that the height of the triangle has the value of 4. And now that we have both the base and the height of the triangle, we can go back to using the formula for the area of a triangle, which is half base times height. But I'm going to stop here because the real reason for the video was to show you how to get to this point without the use of a calculator, and I'm sure you know how to plug the base and the height into this equation to get the area of the triangle. If you came up with another solution, I'd be interested to see how you figure this out. Anyway, that's it for now. Thanks for watching.